Hello everybody, welcome from HVACR Design Engineering. I am Tu Yao. Now, I want to talk about star and data terminal connection in three-phase induction motor. Three-phase induction motor are used in almost every commercial and industrial building. Inside a three-phase induction motor, we have three separated coils which are used to produce a rotating magnetic field. The stator is the stationary part of the induction motor. Rotor is the moving part of the induction motor. Induction motor is an AC alternating current electric motor. In induction motor, electric current is flowing into the stator winding for creating the magnetic field for rotation of the rotor. When we pass an alternating current through each coil, the coil will produce a magnetic field. But if we were to connect each coil to a different phase, the electron in each phase change direction between forward and backward compared to the other phase. To distribute this magnetic field, we need to rotate the coil to 120 degrees from the last phase and then combine this coil into the motor stator to produce the rotating magnetic field. This rotating magnetic field will cause the rotor to spin. This spinning action of rotor is used to drive fan, and etc. On the top or sometimes on the side of the induction motor, we have an electrical terminal box. Inside this electrical terminal box, we have 6 electrical terminals. Each terminal have corresponding letter and number. We have U1, V1, W1 and W2, U2, V2. We have our phase 1 coil connected to 2U terminal. Phase 2 coil connected to the 2V terminal. Phase 3 coil connected to the 2W terminal. Here is a real-world example of three-phase induction motor electrical terminal. Terminals are in different arrangement from the top side to bottom side. We now bring in the three-phase power supply and connect these to the respective terminal. We always connect supply side to top side of U1, V1, W1 in terminal box. Now for the motor to run, we need to complete the electrical circuit. There are two ways to complete electric circuit. First way is data configuration. For this data configuration, we connect across the terminal U1 to W2, V1 to U2, W1 to V2 with terminal link. Now we pass alternating current AC through three phases. We see that electricity flow from one phase into another as the direction of AC power reversing phase at different time. The other way that we can connect the terminal is to use the star configuration. In this method, we connect all together to W2, U2 and V2 with terminal link on only one side of the motor terminal that is not connected to supply line of L1, L2 and L3. When we pass alternating current AC through the coil, the electric current are shared between the phase at the terminal. To change the star or data configuration, we have to physically cut the power and open the motor terminal cover and then rearrange them. In data configuration, supply voltage of 400 volt means when we use multimeter to measure the voltage between any two phases, we will get a reading of 400 volt. If we measure across the two ends of the coil, we again get the line-to-line voltage of 400 volt. Let's say each coil have resistance of 20 ohm. By ohm law calculation, current I can be get 20 ampere by voltage V divided by resistance R. This 20 ampere can be also get when you measure ampere with kilometer. Current in the line is get by current in the coil multiplied with square root of 3. In star configuration, when we use multimeter to measure the voltage between any two phases, we will also get the reading of line-to-line voltage 400 volt. In star configuration, all the coils meet at the neutral point. This time, we measure the voltage across any coil. We get the lower value of 230 volt. We get 230 volt across each coil because we measure between the phase and neutral point. You can also get 230 volt across each coil by line-to-line voltage divided by square root of 3. Let's say each coil have resistance value of 20 ohm. By ohm law calculation, current I can be get 11.5 ampere by voltage V divided by resistance R. In star configuration, line current is equal to coil current, so line current is also 11.5 ampere. Now you can understand star configuration is less voltage and less current usage compared to the delta configuration. Thank you very much to watching my video.